Hello students, Ms. Slyman here with your 2.6 notes on limit notation. Really, we've already been discussing limits. Anytime we've been thinking about end behavior of our rational graphs, so as x went to negative infinity, as x got closer to negative 3 from the left, we were really talking about limits. So there's lots of, whoops, did not mean to do that. There's lots of description here in the notes, so you should really read this and think about how it connects to what we've been saying before with rational graphs. So thinking over here, what's happening here in the graph, we're thinking about as the value of x gets very large in the negative direction, so going towards negative infinity. So this is where we've been talking about x going towards negative infinity. Y approaches the value of 2. So our function value has been getting closer and closer to 2. So let's start looking at the official notation instead of writing out all those sentences like we've been doing. So the official notation, the word for it is limit notation, and we write the limit as x goes to infinity of this. So there's an implied of in the middle here. So this is the equation for our y value. So we're asking, what is happening to y as x is going towards negative infinity? And if we look at the graph, we can see that y is going towards 2. That's why we say equal to 2. If we didn't already have the picture, then we would think about it. And the way that I like to think about it is we're asking, what's happening when we replace these x's with negative infinity? Well, thinking about x going towards negative infinity, that means my y is going towards 2 times negative infinity squared over negative infinity squared minus 9. Well, of course, having infinity squared is a huge number. Subtracting that 9 isn't really changing things. And really what it means is that this top number is just a little bit bigger. This top parentheses is a little bit bigger than this bottom one because I've subtracted this 9, but really they're about the same, so it's like they cancel out, and I'm left with just a y value of 2. Now, of course, infinity is not actually a number, it's a concept that we get closer to, so plugging it in isn't something that we really want to do. It's just that this is what I'm thinking about to get this answer of 2 if I don't see the graph. But if I do see the graph, then I can look at it and be able to answer. So with what's occurring at A, that's up here. No, sorry, that's over here. So thinking about what's occurring at A, well, that's as x is going towards infinity. So we would write down the limit as x is going towards positive infinity of our y value. So I can plug in this whole function, or I could also write a y here. And now I'm going to look at my graph and I see as x is going towards infinity, my y value is going towards 2. All right? Vertical asymptotes, they cause a problem. And thinking about vertical asymptotes, if we tried to just write x is going towards negative 3, well, let's see. All right, here's negative 3 down here. So as x is going towards negative 3, I would say that y is going towards positive infinity. But if I looked coming from the right side, I'd say as x is going towards negative 3, my y value is going towards negative infinity. So there's not one answer to this. Here, it's going towards positive or negative infinity. It matters which way we're approaching from. So down here, this is what we've been writing on all those previous papers. On those previous examples that we looked at, I was talking about thinking about x approaching negative infinity from the right. Well, here's the way we write it. So the plus minus has to do what side of the asymptote you're talking about. So if you're looking at the negative 3 from the positive side, that means the right side of the asymptote. So here, negative 3 from the right, that's negative 3 on the positive side. So looking up at our graph, -3 from the positive side, that's to the right. As we go towards -3 from the positive side, our y value is going towards -infinity. All right, so what's occurring at B? B is up here. So B. Now we've got the limit as x is going towards -3 again, but this time from the left, so from the negative side. And then our equation, 2x squared over x squared minus 9. That's equal to +infinity, and we don't need the positive sign, but I'm going to write it there. So try and figure out what you would write for C and D, and go back and check it in the PDF. And that's this first page, and I'm going to stop this video and join you in the next video.